problem part 2 here. Now when we subtract, we need a common denominator. So the biggest thing, and I'm going to try to trick you, this is what people do, 3x plus 2, just put it together, minus x minus 4, all over the common denominator of 2x plus 3. Now great job, except for the fact that that negative has to distribute, and we're trying to get you to remember that. So that would be a plus 4 right there rather than a minus 4. Now combining like terms on the top, we're going to get 2x. 2 and 4 would actually be a plus 6 all over 2x plus 3. Now if you factor out a GCF out of the 2x plus 6, that's great, but what you're going to have then is 2 times x plus 3 all over 2x plus 3. And you cannot cancel these 2's because this is a monomial, but this is a group on the bottom with no GCF. So either one of these are totally acceptable final answers there. All right, moving on, we're going to move to problem number 12 here. So adding together, we need a common denominator. X to the fourth is going to be the common denominator for the variables. So I'm going to multiply by x squared over x squared. Don't need any variables over here, but we do need a 3 over 3. Okay, so now we have 9 over 15x to the fourth power, plus we have 2x squared over 15x to the fourth power. So we're going to put this together as 9 plus 2x squared all over 15x to the fourth. And a lot of times we can pull out a GCF at the top and try to cancel, but right now we cannot because of the 9 and the 2 and no variables in common. Now over here, this looks really crazy, but it's actually just a problem where you multiply by the reciprocal. So the numerator here is this, and then this division right there, we're actually going to change into a multiplication, and then we're going to flip the bottom fraction. So that's going to be multiplied by 8z all over 10 x cubed y to the fifth. And then we're going to start slicing and dicing. So when we look here, all right, let's look at the x's. There's x squared there, x cubed there, which leaves me with 1x. Sorry, it didn't show up real good. That is 1x in the bottom. With the y's, we got 4 on top, we got 5 on the bottom, so that's going to leave 1y on the bottom. With the z's, we have 3 here, 1 there, so that's going to leave a z squared. And then we can't forget about the coefficients. So looking here, there's anything on top can cancel with anything on the bottom. So take a 2 out of these, that'll leave a 4 and a 5. And actually you can take another 2 out of here with this 6, which would leave a 3. So going through all of this, we're going to have, oh, and then don't forget, I'll grab the red out here. You can see that there's a 5 canceling with this 5 entirely right there. So I know there's a lot on this problem. Slow down and look at it again, or look at the problem from the beginning again. But across the top, all we have right now is the number 2. That is all that's left on top. And on the bottom, we have 3, we have 1x, we have 1y, and we have a z squared. And that's the final answer to that problem, simplified. All right, moving on to here. We should really like when we see these next two, the equal signs. The common denominator is x. I don't multiply to get an x. I entirely want to get rid of the x altogether, or the denominators altogether. So I'm actually multiplying by x over 1 to each part. So actually that'll leave me with a 5x as the lead one, because nothing cancels with the denominator. But in the second one, these x's entirely cancel, leaving just a 2. And the same thing happens on the right side, leaving a 22. So 5x is actually going to be equal to 20, and then x is going to be equal to 4. Final answer. Now over here, and you see these, you got to notice that this is a difference of squares, so we don't even want to look at that. We want to look at it as x plus 4, x minus 4. So I'm going to look at it as that. I'm not even going to look at this. Well, that means I'm going to have to multiply by x plus 4, x minus 4, to all 3 parts. X plus 4, x minus 4, and then here x plus 4, x minus 4. Now, we're going to start with the easy one. When we look at the right side, this entirely cancels with that, and this cancels with that, so all we have on the right side is just 8. Now starting left to right, we have the x minus 4's canceling, but we still have the 4 times the x plus 4. So that 4 is going to have to distribute there, and we're going to have 4x plus 16. Same type of things happening in the middle here. The x plus 4's are canceling. This 4 distributes to the x minus 4. So we're going to have plus, kind of all over here, sorry, plus 4x minus 16. Well, if we see now, the 16's cancel. 4x plus 4x is 8x equals 8. Divide both sides by 8 and x equals 1. Now, in the previous reviews I gave you, this was an undefined answer, but if we look in there, 1 is actually fine. It's not going to create 0 in the denominator, so it's totally fine. All right, finishing up here with 16, the systems. We would definitely want to use substitution or maybe elimination here if you wanted to. That would be fine, but I'm going to show you what most would do in that substitution. So what I'm going to do is I'm literally going to take and I'm going to replace that y right there with everything I know y is equal to. Okay, so that's going to be 3x minus 2 times 5x minus 6, and that equals 5. Now be very careful. Notice I'm going to distribute the negative through here, and that's a definite problem area. 3x minus 10x, and then we got to have a plus 12 equals 5. Combining like terms, we're going to get negative 7x, and subtracting 12 from both sides, we'll get negative 7. So x is equal to negative 1, and then we want to plug that back in. So I'm going to have y equal to 5 times negative 1 minus 6. So my y value is going to come out to negative 5 minus 6, which is negative 11. All right, this one here, substitution would be okay, absolutely. I'll show you elimination. Multiplying the second one by 2, you'll get negative 2x, positive 2y, and then you'll get negative 6. So now I don't even have to look at that anymore, and I turn it into elimination. Now be very careful. Some of you subtract down, and you do this problem incorrectly. You should be adding down. That's what creates them to cancel. If the coefficients were the same, like both positive 2's, then you would have to subtract down to get them to cancel. I really hope you understood what I just said. But adding those two together, you get 0. Now adding these two together, you get 5y, and then adding down, we get negative 5 for our y value of negative 1. And then when we plug it in, either one, I'll plug it into the top one. That would be 2x plus 3 times negative 1 equals 1. Solving this through, you're going to get 2x. It's really a minus 3, so you add that to both sides, you'll get 4. You get an x value of 2. Okay, so you have an x value of 2 and a y value of negative 1. All right, over here, again, this is back substitution. So start with the bottom, take the negative 3, and actually just plug it into the one previous. So what you'll have is 5x. A lot of you asked me about this gap here. Don't worry about it. It just means there's no y's there, and we're just keeping things lined up. But really, it's 5x plus 2z. Well, I know z is negative 3, so I'm going to go backwards through this. And that equals 14. All right, well, that would be 5x. This is really a negative 6, so I'm going to add that to both sides, and I'll get 20. And I'm going to get an x value of 4. Remember, the whole goal is to find x, y, and z. Well, I've got x, I got z, and then I have an equation up top here where I can plug everything into. So plugging everything into there, I'm going to get 3 times 4 minus 3y plus z, which is negative 3, and that's supposed to equal 1. Well, I've got 12 plus my negative 3, so I really have negative 3y plus 9 equals 1. This one's going to come out a little uglier. Negative 3y equals negative 8. And then y is going to come out to 8/3. So I got my x, y, and my z value there. All right, moving on to this one. You guys, again, are doing pretty well on these. Add two numbers together. X plus y has to be 57. That's what sum means. And then they're different. Same two numbers, unknown. X minus y is equal to 7. Okay? So when I go through this procedure, I add down. Again, adding will make those eliminate. So I get 2x, x plus x is 2x, equals add down, and I'm getting 64 for an x value of 32. And then when I plug that in, I'm going to get 32 plus y equals 57. And then I get a y value here of 25. So my two numbers are 32 and 25. All right, finish strong. Here we go. A little concerned about this. We haven't spent as much time on it, but I want to see if you can, first of all, realize that we got to get these both solved for y. So this would be 2y minus 3, equals negative 3x plus 12. And I want to slow down and make sure you understand. All I'm doing is taking this 3x, subtracting it to both sides, and I'm writing it in this form so that we can graph. Okay? Next step is we're going to divide by 2 to everything. Make sure you divide everything by 2. So y is going to be, oh, sorry, I just made a mistake. I'm going back up. I was going too fast. This is less than or equal to, and that's what that should say right here, less than or equal to. I don't flip the sign here, because I'm dividing by a positive. So y is less than or equal to negative 3 halves x, just leave that as is, plus 6. So now I'm going to go graph that. Now the first thing I do is I go up 6. 1, 2, 3, 4, 5, 6, and I'm going to make a point right there. And then now I got to do my slope. Well, my slope says down 3, right 2. So 1, 2, 3, right 2, make a point. Now I could keep doing this. 1, 2, 3, right 2, make a point. But really here, and this is not the easiest for me on this pad, sorry, that should be graphed right through there. Okay? So there should not be 2 lines there. Maybe I should start again. But that should be right through. Wow. Sorry guys, you can laugh at me, it's fun. Alright, we should be graphing below that line because it says less than or equal to. So I'm going to take my highlighter and I'm going to say, alright, in yellow, this is where we're supposed to be shading. Again, it is as simple as, wait, it's literally less than or equal to that line. Where is less than or equal to that line? Or this thing that we're supposed to be calling a line. Alright, I apologize for that again. I feel really bad. Moving on, I'm going to take red. And now on this one, if we subtract x from both sides, we're going to have negative 2y is greater than or equal to negative x plus 3. Now we're going to divide everything by negative 2. Alarm, alarm. What are we thinking when we divide by a negative 2? You got it, folks. Flip the sign. So y is less than or equal to. You guys really have been struggling with this. Negative over negative is a positive. It's not 2. There's a 1 on top. So that's really just a positive 1/2 x. And then over here is a negative 3 halves. Now, negative 3 halves is not the greatest to graph. But since we're just doing an inequality and shading, it's not that big of a deal. We should be able to just guess. Negative 3 halves is basically down 1/2. So I'm going to start right there, down 1/2, and then I'm going to go up 1 over 2. So up 1 would be here, and then over 2 would be there. So I'm going to graph this line, and notice here it's a solid line because we do not have, or we have the or equal. Both of these are solid because it's or equal. If you look at independent review number 1, it was just that sign, so they were dashed. Okay, anyways, we are now going to graph this line. We're going to have to shade this line. And which way are we going to shade? Well, it says less than or equal to. So here's the line we want to shade less than or below the line. So that's actually all of this. Okay, they're both on the same graph. So now I'm going to take blue and I'm going to say, all right, well, where's my final answer? Wherever the shadings cross. Just yellow, no shading, just red. But this region here is the one where I actually have yellow and red. So that's my final one there. Okay, we got a big test tomorrow, so all I want to say to you is good luck, and I'm going to be bold here. Remember, you can be mad if you don't get a good score, but you got to put the time in to get the good score. So I really hope that you study and you have a fantastic test and you end quarter 3 strong. Thank you. This has been fun. If you haven't already looked at the other video I made on the independent review number 1, I encourage you to do that before your test.